This is another video to help you understand the concept of truth tables. Using truth tables to determine the validity of an argument. So now we have a little more complex problem, but the basics of truth tables has not changed. We start out with our P and Q, our original statements of fact. P and Q. We know that the conference is in Sydney, and we state that Sue is the presenter. Either they are true or they are false, and these are the possible combinations of them. Now we're going to put this together and make combinatorial statements and come up with a conclusion. We say if the conference is in Sydney, changing that to a mathematical statement, if the conference is in Sydney, that's P, then that implies Susan is the presenter, Q. Very straightforward. The premise 2 is the conference is not in Sydney. That would be not P. The conclusion, therefore, Susan is not the presenter, is not Q. Those are the only pieces that we know. Once we get to that, we're only dealing with a mathematical variables, and that's all. Don't worry about whether she's conference. If you've got these parts correct, then the rest will fall into place for you correctly. So if something goes awry here, either you made a mistake in making the truth and false statements here, or you failed to write this correctly up here. So I start with my original truth statements. I'm going to put them down in the order in which I need to use them to make it easier for myself. I'm going to start with premise 1. P implies Q. So I look over here and I remember that true implies false is the only one that turns out false. And so true implies false. This is the only one that always will be false. Everything else is true. And so I just fill that in. I don't have to really think about what true implies and all these other steps, right? The other piece is premise 2, which is not P. Well, not P is going to change those P into their exact opposites. Okay. And now I put them together. Premise 1 and premise 2. And that's written as here's premise 1 and here's premise 2. And I'm putting them together. And if they're both, what happens when I'm looking at both of them together? So the first premise and the second premise, and I'm looking at an and statement. And again, I don't have to think about all of these truth columns. I just need to remember that I need 2 T's to make it true. So here's the truth, and here's the truth of these 2 premises. And so therefore these 2 must be false. Now I'm ready to put the pieces together. I need the conclusion. The conclusion is therefore not Q. So I look over here and negate Q. That must be false. That must be false. I'm sorry. Let me erase this. Yeah, that's right. That's what I wanted to do. False, not. This one is not Q. This one is true. Not true is false. Not false is true. Okay. Now I'm ready to put the whole thing together. Here is my 2 premises, which is this column here. And I'm going to imply this. This is the conclusion. And so these are my last two columns here, and I'm going to look at them, and I'm looking at, again, the if then. The only one that's going to be false is true implies false. So this one is going to be false. The rest are all going to be true. And I have made the rest of my statement what I needed for the thing. And is the argument valid? No, because if the argument was valid, the ending conclusion, all possible combinations of P and Q would be true. And I have in this example, one false statement. So therefore, the answer, is the argument valid? The answer is no. Thank you for listening. I hope that this was helpful to you. If you have any questions, please post them or send me an email. Thank you.